Okay, in this video we're going to try and demystify statistics. Now, in statistics we're concerned with collecting data, and data is usually from observation and collected information. Ideally, what we want to do is poll or do a census of the whole population, but because these are large numbers, it's difficult to do this. So what we do is we take a random sample representative of the whole population. When we're collecting primary data from a population, we can either do a census, which is everyone in the population, or we can take a sample which is representative of the population. Now, when we're sampling, we use a questionnaire, and the questionnaire has to have a minimum of 3 responses, and these responses should have a time frame. The question shouldn't be leading questions such as you should eat healthy food, yes or no, and the subject should be able to tick only one box. There shouldn't be like overlapping where, say, in this case I'm making the boxes and I'm labeling them with hours, so 0 hours, 1 to 2 hours, and then 2 to 3 hours. So there's some overlap there. So if we're doing 2 hours of an exercise, say, then there's more than one box we could tick. The other thing is we don't use leading questions, and also we don't use personal questions which participants wouldn't like to answer. Ideally, what we want to do is take a survey or a sample of the whole population. Quite difficult to do when the population is quite large. So what we do is take a sample, and each item should be equally likely to be chosen in the sample. In an unbiased sample, it's usually representative of the population. So we have to remember that there's always going to be a sampling error due to us looking at part of the population rather than the whole population. So how can we reduce these sampling errors? Well, there's a few ways we can do this, and the first way is by random sampling, where we assign numbers to the objects and then randomly pick numbers, and this gives us a representative sample. In convenience sampling, we take the next 20 items or the next 10 items, and that's our sample. In systematic sampling, we choose a starting point and then at specified intervals take our sample. In cluster sampling, the objects are usually in clusters, and then we sample the cluster. This is usually not representative of the population. In stratified sampling, the group sampled with the sample size in proportion to the group. It's quite complex and needs a sampling frame, but it does give us a representative sample. Here we're going to have a look at types of sampling bias and how to get around this. Bias occurs due to undercoverage from the sample being too small. There are different types of bias like response bias, interviewer bias, the wording of the census, and also a non-response bias like if we're doing a survey by mail. To overcome selection bias when we take a sample, the solution is to take an independent sample. In measurement bias, we can get a distortion of information, and we get around this by having a control group or a placebo group. Then in recall bias, where people can't remember information. What we need to do is we need to confirm the information with reliable sources. And then with expectancy bias, where we get we're expecting a certain result, what we need to do is have a double-blind design where the subject doesn't know and also the person doing the survey doesn't know what's being tested.